Welcome back. It's been a little more than 10 minutes. One thing that students often get confused about is they feel like it has to burn for exactly 15 minutes. Or if the lab directions say burn for about 12 minutes, say it's got to burn for 12.000 minutes, okay? As long as you have the initial time that you started to let it burn and the final time, it doesn't really matter because all we'll do is we'll set up a ratio at the very end, okay? We're going to set up a ratio as to what will happen to mass and volume over time, all right? So now that we've recorded all of our information, we saw that the candles are not radioactive. We've noticed that the hot air rises, okay? We're seeing that sometimes maybe a drip might have come down, but the drip that's come down has landed on the container, on the little metal cap that's in the bottom. Uh-oh, okay? Maybe we spill, okay? Hopefully we don't spill, okay? If we do spill, we want to collect all the wax afterwards. So this one I made a little boo-boo there. I spilled a little bit. I don't want to do that, okay? This one I didn't, but we're going to blow the candles out. We'll record. We'll see there's some smoke and everything else, but we're going to go ahead and record the mass afterwards. So here's our balance. We're going to turn it on. We're going to tare it, make sure it's reading 0, and then we're going to record the mass afterwards, all right? Again, we've collected all the wax before and all the wax afterwards, okay? And we're going to see what happens to the mass. And same thing for this one, okay? There's a little bit of a boo-boo there, okay? I spilled a little tiny bit, but that's almost insignificant, okay? So we're going to record the mass afterwards of the candle. Now again, you only have to do one of them. It doesn't really matter, okay, what color you have. But we're going to see what happens to the mass as you burn a candle, okay? We will also go ahead and do the same thing. We'll record the volume using water displacement technique as well, okay? Now, one of the problems you'll run into, okay, is that some of the wax might have dripped onto here, okay, and there might be a little bit that's on here. If that's the case, then what you might want to do is just add maybe like 1 or 2 milliliters of when you record your final volume, okay? We'll wait until this gets nice and hard. It's nice and hard. We'll go ahead, record our initial volume for our water. We'll put it in, okay? We'll see that, oh, this one floats as well. We'll push it down, okay, and record our new volume. Now again, with water displacement technique, it doesn't matter where you start. It just matters that you record the initial volume and the final volume afterwards, all right? So as a result of pushing it down, we record our new volume, and we see if the volume changed over time, and we'll see if the mass changed over time. Oh, we forgot about height. Okay, we can also record the height and see if the height changed over time. Notice we will have to record the initial and final time that we let the candle burn for, as well as our initial mass and our final mass, and our initial volume and our final volume. So we'll record all that information. From there, we're going to go ahead and do some calculations. Everything else is going to be calculations. You might have to calculate the density. Seeing that this is the case, okay, in which the candle floats in the water, we should be able to come up with a reasonably good estimate. If your estimate is wrong, okay, and if you say, wait a second, okay, I'm coming up with a density value that doesn't support this idea that the candle is floating on the water, you might have to put a little footnote or an asterisk by that. So with this information, we can actually calculate when the candle will be totally gone. All right, there's some math involved, and we can do that using the height, the change in height, the change in mass, or the change in volume. Now, when we do the change in mass or the change in height, and we determine when the candle will go out and be extinguished entirely, those two answers might not be the same. So even though we measure the change in height or the change in mass over time, okay, it seems that if we do the math, we'll get two very, very different answers. And that's okay. One thing that people also will get confused with is they will think that the mass does not change over time, and that is wrong, okay? When you go ahead and do this experiment, you'll see the mass before and the mass afterwards decrease over time. So that's our candle lab and how we work through the calculations on the candle lab. We will give you some data, and you'll record some actual data if we are back in school in 2020. Thank you. these are the quantitative measurements of this candle, and we're going to go ahead and give you the data. This is the data for our 4-level class. Mass before burning, 38.85 grams. The height of the candle before burning, again, it was this candle here, the smaller one, 9.4 centimeters. The width of the candle I measured more carefully to be 2.4 centimeters. The volume of the candle, you should be able to calculate using the diameter and the height. I will give you the reminder, volume equals pi r squared times height. Make sure you are using the radius and not that diameter. The volume of the candle using water displacement. We have the water only, and then we have the water and the candle. The difference between the two was the volume of the candle. We did push it down a little bit with some sort of small tool. We also have our mass after we burned it. Notice the mass did go down. Some people estimated that the mass of the candle stays the same. The mass does go down after you burn a candle, even if you collect all the wax afterwards. The height of the candle went down as well, 8.5 centimeters after burning. The volume of the candle using the height and the diameter. The diameter didn't change very much, so we're keeping the diameter the same, but you should be able to calculate the volume afterwards. And the volume using water displacement technique is as follows. Again, we do the water only and the water and the candle, making sure we push the candle down a little tiny bit to get a really good reading for our volume. The last thing is we would need to record the time. The exact amount of time is not important. What we'll do is we'll get a ratio at the very end. So the time to start, that we started the candle was, here's our time to the nearest second. This was in the afternoon. This was the time we have to extinguish a candle. That's the time that we extinguished it. And the difference between these two, okay, would be the time, oh, here we go, okay. The difference between these two would give us the time that the candle actually burned, all right. And then we, of course, would convert that to a decimal value before we do any kind of calculations. So that is our data for the Candle Lab. Good luck on all the calculations.